How's it going, everybody? In this video we are going to take a look at connecting our peers from router 9 down to R10 and R14 over our frame relay network. And then what we're going to do from there is we're going to talk about the 4-byte autonomous system number and the private AS number and exactly how that comes into play. And if you're not familiar with the 4-byte autonomous system number, the general idea for this guy was to expand on the 2-byte ASN number, which I'm pretty sure I covered this already, but the idea behind the 4-byte ASN is to double up the amount of autonomous systems that are available from the 2-byte autonomous system, and then doubling that to 4 bytes, and therefore you're doubling your ASN space. So that's the general idea behind how they work. Now, the way that this is actually going to be set up is, as you can see from router 9, I have my entire BGP routing table. Okay, we're in good shape with how that is set up. Now, the main thing that you want to pay attention to is we have a bunch of RFC 1918 address space. Now, by default, 99% of the time, you're not going to see RFC 1918 address space inside of the global routing table. Now, you might ask, well, why is that? Well, the main reason for that is because of the fact that most providers will drop it if they receive it. And the reason that they will drop it is because if you have, say, two different customers both running the same address space range, so they're both running 10/8, and they both have, it's not entirely unplausible, but they have the exact same subnets in use. So they're using 10.1.1, 10.1.2, 10.1.3, so on and so forth. And they have several sites. So they're going in, they're doing 10.1 is their headquarters site, and 10.1 is 10.1. 2 dot something is something else, and you could very easily subnet that out to be very broad if you really wanted to. The drawback to that is it's all RFC 19 address space, which you can pretty much bank that most of your customers are going to be using the same address space, even if they're using 172 or 192. The idea behind this is when you're dealing with the RFC 1918 address space, you're dealing with private IGP routing in most cases. You're not going to want to have that going over the public internet, because if you receive a route in via BGP that's a 10.1.1.0/24, well, you look at that and you go, oh, well, hey, I've got that same address here locally. So instead of trying to route out over the internet, you're going to route to yourself. So the idea of having RFC 1918 address space, it's a bad idea. So normally what you're going to do is you're going to be NATing that. So you're going to be NATing over to, you're going to have a dedicated setup to where you're going to be NATing internal address space over to private address space, and we'll talk about that more in detail later on. We'll NAT over coming up here momentarily when we get into services and stuff like that, because NAT is a service, and get into all that stuff. But the one thing that I want to make sure I cover is when you're dealing with the 4-byte autonomous system number, it's relatively easy to work with. Now, in order to get this to work, you need to go to global config, and the 4-byte ASN is going to be denoted similar to the 2-byte ASN, which is going to be router BGP ? And notice you got two different situations here. You got 1 through 4.2 billion and 1.0 through xx.yy. So this could be a little misleading. You're not sure exactly what it's asking you. But I'm going to use 10.10. Okay. Now if I hit enter and I type in do show run pipe section BGP, I'm going to get router BGP 655370. Well, that's not 10.10, is it? Well, in order for it to look like this, I would have to type in BGP ASnotation ? Is going to be dot ? And hit enter, and then hit that show run BGP again, and that will change it over to 10.10. Okay, so I changed it over to 10.10. If you happen to have if you're running BGP and you're running the 4-byte ASN, and you send that an update to a router that is not running a 4-byte ASN. So, for instance, anything prior to 12.4.24t, that route will show up as a 23456 in the autonomous system number. That's an indication that you're receiving an update from a 4-byte ASN capable neighbor, and that route is being received by a neighbor that cannot perform that same level of BGP. The routes will still propagate, but the routes will show up kind of weird, and you might be like, okay. So the general idea here now is what we're going to do is we're going to type in neighbor of 101.0.0.9 remote AS of 789, and I'm going to do the same thing on 9. I'm going to go to global config. I'm going to type in router BGP 789. Type in neighbor of 101.0.0.10 remote AS of 10.10. And we should form an adjacency because we have layer 3 reachability. So momentarily that should show up. So and there it goes. So it means we have our neighbor relationship up and running. So now if I go to 10 and I go show IP BGP, I'm receiving the full route, but it's coming from router 9. And notice how router 9 is sending me his autonomous system number over here, 789 for all routes. Then I have 1, 2, 3, 4, 5. Then I have 15. That's an indication to you and I that to get to 15, we're going to be coming down here for these guys. So I have the 155. So if I want to do a trace route to 155.0.0. Or I'm sorry, 152. Let's do 152. 152.0.0.2. I'm going to be able to get to router 7. And the problem with that being is, or 79.7. Yeah, the problem is going to be that this guy doesn't know how to get back. So that's going to be the problem. So you have to advertise a route in to get that there. So, but if we look over here on router 5 and we do a show IP route, or I'm sorry, show IP BGP. Let's advertise that network in 101. 101 isn't being advertised yet. So let's go over to 10. We're going to go to global config. We're typing router BGP 10.10. Type in network. Actually, let's just do a redistribute connected. Make it simple. We go to 5. We hit the up arrow. We go down. We go through. We have 101 is there now. But you notice how 101 it shows up with the 655.370. And let's go over to 14, do the same thing. But we're going to go to global config. We're typing router BGP 14.14. We're typing BGP ASnotation dot do show run pipe section BGP. Shows up as 14.14. But if you look on router 5, shows up as 655.370. So in order to change that, you got to go to router BGP 12345 and type in BGP ASnotation dot, and then do a show IP BGP again. Now it'll show up as 10.10. So that shows you that we have a 4-byte ASN. Now if we go over to 14 and we type in neighbor of 101.0.0.9 remote AS of 789 and do the same thing on 9 and do a neighbor, but we're going to do 14, but we're going to go to the end and we're going to type in 14.14. We'll get that neighbor relationship up and running. That's good to go. We'll type in redistribute connect, or I'm sorry, on 14 we'll do a redistribute connected. And then we'll go to 5, we'll do a quick show IP BGP, and then we're going to be able to, well, we should see, as soon as the update comes through, we should see 14.14 coming in too. Let's see if, do I have anything on? Do show IP interface brief. I do have. Okay, that's where it is. So we should see 10.255, 14.14 coming through, and then right there. Now 14.14 is coming through, and so now if I do a trace route to 10.255.14.14, I should be able to get all the way there, and I can. So that's a good indication that I have BGP completely running end to end. Now, there's a question. What if I don't want to advertise my directly connected network in? How could I make that work? Well, as long as you're learning a default route from the provider, what you're going to do, and this is where a caveat comes into play, and it's not really a caveat of any real sorts. More or less, it's just a way for you to, it's with the default route. If you receive a default route from the provider, and the default route comes in, you're going to send the traffic to the provider regardless of what's going on. So you advertise you're receiving their default route. You send all your traffic that you don't know what to do with to the ISP. Now, let's assume you're running BGP 100, and then one of your remote sites is also running BGP 100. Now, the kicker with this is, if you're running BGP 100 on two different sites, but you're only receiving a default route from the BGP, you're not going to look at the AS path information. You're just going to send whatever you don't know about to the provider. And then that's a way for you to work around the allow ASN stuff, to where if you have the same autonomous system, if you have two different locations running the same autonomous system, you'd have to disable the loop prevention mechanism of the AS path lookup and to allow your routes to come in. But if you have a default route coming in, you bypass that loop prevention mechanism because you don't care what you're receiving from the provider. Whatever you don't know about, you're just going to send to the provider. And that's all you're going to be receiving from the provider is a default route. So it's not super uncommon, but the general idea is that if you are receiving traffic in that you don't know what to do with, you give the ISP that information, and there you go. So let me do a show IP BGP here. And we have 655.370 coming here, and then we have 917.518. Can you get an idea of which autonomous system that's coming from? I'll give you a hint. I'm going to circle which particular router that's happening from, because this guy isn't doing BGP ASnotation dot. He's just taking whatever he's learning in, and he's saying, okay, well, you must be to this guy, right? Now, the problem we're going to have is later on down the road when we get into DMVPN and get this situated, the problem that we're going to run into play is because we're doing a redistribute connected on these boxes right here, that's going to give us a hard time later on down the road. So what we want to do is on router 9, we're actually going to type in network of 101.0.0.0, and we're going to give it a network mask of, the mask of /24. Now the reason I'm going to do this now instead of doing it down the road is it's going to save us some time when it comes to getting the advertisement running. So now what I can go on 10 is I can type in no redistribute connected, and I can go in and I can type in network of 10.255.10.10 with a mask of 32 bits. And if I go back over to 5 and I hit the up arrow, I'll still get the route in, as you can see. I still get the route in, but as soon as I do a clear IP BGP star soft, okay, I've lost the route now, which is fine. I'm going to go to 14. I'm going to type in no redistribute connected as well, but I'm going to type in network of 10.255.14.14 with a mask of 32 bits. Because I've punched in all of these, all of the loopback masks in as /32. So I go back to 5 and I hit the show IP BGP. Now I've got it back in, but notice how it's advertised. It's advertised as an internal route. And as soon as I do a clear I should receive that route in as well as a. This one should come in as internal now, because of the way that I'm advertising it. And there it is as well. So now it's coming in as an internal route, not a redistributed route. So we have that. So, and the reason I want to do that is because we're going to be getting into DMVPN here very soon, and how that would be affected. So now the other thing we have to touch on now is the private AS number. Now remember, the private AS number is going to be any autonomous system number that is 655 or 65412 and above. Now, normally, if you are running into situations where you are using the private AS number, you're going to want to. Typically, this is only used in confederations, but it is possible to use this in production. I don't recommend you do that, but you can if you'd like. But that's the general idea behind the idea behind the private AS is it gives you the ability to run it privately. So you can have, say, a backdoor link between two different sites, or you could use that as your, say you've got a router running DMVPN and you want to run it dynamically. So you run iBGP over your DMVPN infrastructure, and that's how you get the job done. So the main reason why you wouldn't want to have a private AS number in the global internet table is because of the fact that more than one customer may actually try to use that same autonomous system number. And because of the fact that the autonomous system number directly relates to the AS path, if you have the same AS path length to one customer as you do another one, and they're both advertising different routes, you could potentially black hole the internet, or you could be going to the wrong destination. You know, there's different things that come into play with that. And one simple way to get rid of the private AS is to use the remove private AS command. And the general idea with this is if you have the private AS configured and you're going to hand off to an upstream provider, which is going to be your the provider that's going to be actually giving you access to the internet, you can go in and type in neighbor and whatever that IP address is and type in remove private AS. And what that's going to do is it's going to remove your autonomous system number from the AS path, and the provider is going to reallocate their number in place of yours. Now, it doesn't always happen that way, and there's some caveats to it. And I looked up a pretty good doc, but it's about 10 years old. But the general idea is still maintained. And for one, you can only use this solution with external BGP neighbors. And if the update only has a private AS number in the AS path, BGP removes these numbers. So, and if the AS path includes both private and public AS numbers, BGP does not remove the AS number, and the situation is considered a configuration error. It kind of like just rejects the command. If the AS path contains the autonomous system number of the eBGP neighbor, BGP does not remove the private AS number. And finally, we have if the AS path contains confederations, BGP removes the private AS number only if they come from the confederation portion of the AS path. So there's some considerations to maintain, but the general idea is if you have private AS numbers, you want to remove them. Again, because more than one customer could potentially use that. But the same thing when we talk about MPLS, where if you have two customers running the same address space, and they advertise those routes into the internet, or into MPLS, you could potentially routing customer A's traffic to customer B's networks, and so on and so forth. It gets a little, it's kind of hairy. So the idea is to remove the private AS number whenever you can. So that's the general idea of how that would work. So I've never actually ran into that in production. The few times that I have had to deal with BGP on the edge, they've always owned their own autonomous system number, and I've done some consulting where I've had to go out to IANA and go out and get the paperwork started to get a customer their own public autonomous system number, and they eventually didn't go with BGP because there was other easier routes to go, and they had like 7 or 8 different options, and BGP was one of them. but they decided not to go that route. It was easier for them just to have like a dedicated fiber connection with a /24 subnet associated to it. I let the provider do the aggregation for them. And remember, a provider aggregatable means that the provider is going to advertise your subnet on your behalf, so you don't have to worry about it. Provider independent means that you have that autonomous system number provided to you from a local registrar. You assign that autonomous system number to your router or your firewall or whatever the case might be. You peer with the provider, and then you advertise your routes through that. So you use the network command, and then you would kick it out. So depending on how the situation would work, depends on how your deployment would work. So again, every company's needs are unique to themselves, and their individual needs and necessities and things like that. So that's pretty much it for this video. There's not a whole lot else to cover other than the best path selection algorithm, which will cover the first 5 or 6 options, which is going to be the weight, the local preference, the locally originated routes, AS path. We'll talk about what's the other one? We'll talk about MED. There's and then eBGP over iBGP and things like that. We're not going to go super deep into the best path selection algorithm for CCNP, but if you are going for CCIE, I would recommend knowing them all the way down to the lowest metric cost to the next top, things like that. That's the level I need to know it at. I don't think we need to go that far in best path. And then there's a couple of other things that you need to know, like aggregation and things like that, and we'll talk about that coming up. I have had some issues with GNS3 though with getting aggregation to actually work the way that it needs to, and similarly with the way that I've had issues with OSPF and doing the filtering with the Type 3 LSA and doing the area range and things like that. The general idea with aggregation is the same thing as summarizing with an OSPF or EIGRP. It's just that you have some additional capabilities you can use to get the job done. So that is pretty much it for that. We're going to get into the best path selection algorithm in the next video, and I will start breaking down individually the different ways you can do with it. And there's a question: are you going to go? How deep are you going to take the BPSA? Well, I'm going to take the BPSA, or the best path selection algorithm. I'm going to take that. I'm going to show you a couple different ways to manipulate each one. And so whether it's you use the wait command for a specific subnet, or the way you're going to leave the network, and the first thing we're going to talk about is the importance of understanding which particular attribute affects what type of routing. So local preference is a good way to get traffic off of your network, where MED and AS path is a good way to influence traffic into your network. So depending on the situation will determine how you would want to affect that. We will talk about that as we go along, but it's important for you to realize the details. The devil is in the details, to be honest with you. And another question is, how much more BGP is there to cover? Not a lot. I'm definitely not taking it as deep as I would with CCIE, simply for the fact that I don't see the need for it at the CCNP level. And then as soon as we're done with BGP, we'll be getting into the VPN technologies, and IPsec, GRE, DMVPN, EBN, things like that. So I think you guys are going to be getting in for a treat. Now we're getting into the newer, cooler technologies. So I hope this has been informative for you, and I'd like to thank you for viewing.